So today we're going to start section 10.2. We'll take a couple of days to cover this section of material. 10.2 and 10.3 are really just one giant section that they've split apart. It's just a continuation. It's 10.3 of 10.2. And so we're going to start today with this. And everything you're going to see really in 10.2 and in 10.3 are going to be graphical ways of displaying information. So we're going to start with a pictograph. So pictographs occur very, very early in schooling. So my daughter is in first grade, and she's done pictographs. Hers are very simplified because she's in first grade. But you see pictographs occurring very early. They use pictures to represent tallies within a category. So they can go from left to right, or they can go from top to bottom. She's filled in pictographs with like numbers of crayons where she's had, she's counting crayons in a basket or something like that. And she's put little, that color and filled in little boxes to make it a certain height so you can see like a bar graph kind of like that. But she's also done things where she's drawn it sideways. So in a pictograph that we're going to do an example. My example is not appropriate for first grade. It's going to say right there. The Automobile Club of America considers holiday weekends to start Friday at 6 p.m. and last until Monday at 6 p.m. If 150 people died on such a weekend by 6 p.m. on Saturday, 80 people from 6 p.m. Saturday to 6 p.m. Sunday, and 100 from 6 p.m. Sunday till 6 p.m. Monday draw a pictograph for the data. So probably not going to present this to your first graders, right? It's kind of sad. So one of the things that happens with young kids with pictographs is that whatever image they're using represents one person. You can see we have three separate places where we have numerical values that we're representing: 150, 80, and 100. So we don't want to do anything that's going to actually make one person equal to one image, because I don't want to draw that many images. So what we're going to do is we're going to identify some kind of an image and let it be worth so many people. So in this particular one, you might choose that the image is worth 10 people. All those numbers are very nicely divisible by 10. You could choose that the image is worth 20 people. And I'm going to do 20 just so I can show you what happens when it's not quite divisible, but you use an image that's nice anyway. So obviously 80 and 100 are easily divisible by 20, but the 150 doesn't quite work. So we're going to do three different lines. I'm going to do mine horizontally to represent our three different time periods. So I need 4 lines actually, but and then so we're going to represent Friday to Saturday, right? Saturday to Sunday, and Sunday to Monday. And I'm going to use an image that's really easy to divide in half, and I'm going to use a heart. The reason I use that is that if you use a rectangle, or a square, whatever, if you divide it in half and you're not careful, like if you just divide it in half by doing this, sometimes, and you'll finish it out, you're left wondering, well, is that a whole thing, or was it half and I didn't draw it very well? You know what I'm saying? You can use squares. There's not that you can't. You just have to be more creative on how you divided it to be obvious. If you divided it into half of a triangle, or halving it by making it a triangle, you could do that. I like using hearts for something that I just want to half, because it's really easy to see that this is half of a heart. It's absolutely clear. So that's what I'm going to use. All right, so up here, I need to identify what my heart represents. So my heart is going to represent 20 people. I'm going to have to put a little bit more detail here in a moment, but 20 people is my heart. The closer you can make your image, whatever you're doing, to the same size every time you draw it, the more accurate it's going to represent visually what you're meaning. So we're going to start with my 150 people. If I have 150 people, how many whole images of the heart will I have? 7 is right. Yeah, I'll have 7 of them. So there's 1, 2, and I need to make sure that they're far enough over that I can, good grief, that I can line things up vertically so that they match. I'll show you that in a minute, but so there's my 7 whole hearts, and then that's the place where I'm going to need a half of a heart, right? So if you wish, you can actually do a whole heart and then erase part of it, or if you're good at having your heart as you're drawing it, do it that way. And we will complete our half heart by that. So there should be 7.5 hearts. How many from Saturday to Sunday? How many? 4. Yep, 4 it is. So here I'm going to have these 4, but the 4 need to line up so that they're directly under the first 4 of the first line. And again, I know you don't have copy-paste for most of what you're working on. You're working on paper. But do be careful that the images look like they're about the same size. Because if I end up drawing things either not lined up or not quite the same size, you can see very quickly how you have to then count, which is kind of the whole point of not, I mean, it's kind of the whole reason we don't want to do it with images that don't line up or that aren't the same size or whatever, is that there's an imagery issue with how many are there. So we want them to be the same size, same shape. How many will I need for the Sunday to Monday? 5 is right, yeah. So there's 1, 2, 3, 4, and 5. Okay, this is our basic pictograph. We're missing one thing that I haven't mentioned yet, so I'll mention it now. Every image we draw, graphical image we're drawing, in all of these sections of material in Chapter 10 need to have a title. They need to have a title and a key when necessary. We've already done our key. Our key was that the heart represents 20 people. So we've done that. But we need a title for what this is representing. You can put it on the top. You can put it on the bottom. You can put it on the side. I don't care as long as it's there. So I've got a little bit of space on top, so I'm just going to write mine on top. This is the deaths on a holiday weekend. When that heart represents 20 people. You don't necessarily have to have a heart representing 20 people up there. You've drawn it at the bottom, but it needs to be somewhere. So it can be incorporated within your title or a separate piece, but it needs to be there somewhere. So this is a pictograph. If you have small amounts of data, you might let your images represent one person or one object. That's okay too. It just depends on what you're working with. Any questions on pictographs? Okay, the next one we're looking at is called a dot or a line plot. I refer to them as dot plots because we're going to have something later called a line graph. You don't want to confuse a line plot and a line graph, so we'll call them dot plots. They are a quick way to display data with fewer than 50 values. Okay, so not trying to throw things off by telling you it's 50 values. You don't need to count and make sure there's 50 to use it or something like that. It's just got a small number of values is the point. So with a dot plot, we're going to do this example number 2. This is the mass in kilograms of each child in Mrs. Good's class. And we're going to make a dot plot for the data. So what a dot plot looks like is it looks kind of like having a number line. So we're going to draw a long number line. The number line is going to start with our smallest value. So looking up at the data, what's our smallest value you see? 39. And what's our largest? 49. So I need to start at 39. I need to go to 49. And I need I'm going to make a hash mark for every unit across that I am. So instead of writing the 39 and the 49 down first and trying to hash it out evenly between, it's probably easier to just make your even hash marks and label them as you go. So I'm going to start with 39. And then we have 40. 41. I'm trying my best, and you should as well, to make sure that they're evenly spaced. Something like that. Doesn't have to be absolute perfect, of course, but it should look reasonably good. Depending on how long your dot plot goes, you might not label every single value. I did here because most of these values, if not all of them, I think all of them actually occur in my data set. But if your data had gone from, say, 0 to 50, maybe you only labeled every 5 units, right? That would be fine. You could maybe make a hash mark for every one of them, but only label every 5th unit or every 10th unit or something like that. So maybe instead it would look like, you know, labeled like this. You only labeled every so often, right? I'm going to put them back here in a second, but, right? So if there was something like that going on, and it would be reasonable too, okay? Okay. What we're going to do then is we're going to take each data value and we're just going to go from left to right. And so I'm going to do like the 40 and the 42, and then the 49 and the 41, and then the 43 and the 42. I'm just going to do them pairwise. And we're going to make an X. And we're going to make an X above the location where that value is. So this one says 40. And I'll do this one freehand. I'm not going to copy paste anything. But you're going to make an X at 40. Okay, so it's sort of hovering above the hash mark. And we're going to do 42. So again, the X's should be approximately the same size. They should be approximately distanced the same amount apart. So we're just going to go down the list. So I have 49 and 41. Okay, the 49 is going to be the hardest because I've scrolled out so far. It's a little too small. There's 49 and 41, 42 and 43. Okay, so when it duplicates, you stack them. 42, 43. 48 and 39, 46 and 41, 42 and 40, 49 and 45, 39, 43, 47, 44, 49, 42. Okay. It's fairly reasonable. Scale-wise and so forth. You wouldn't have to have an X in every single location. This one worked out that way, but it certainly wouldn't have to. So the only thing that's lacking on this is the same thing that was lacking at the very end on this. It's a title. What in the world is this representing? Well, I'm going to put mine underneath this time because that's where I have a good amount of space here. This is the mass in kilograms. That's important. Pounds would be quite different, right? In kilograms of children in Mrs. Good's class. Any questions? All is well? Okay, the next one's one of my favorites. It's called a stem and leaf plot. A stem and leaf plot is similar to the dot plot. It is drawn vertically, though, instead of horizontally. We drew that last thing horizontally. The numbers on the left are called stems, and the numbers on the right are called leaves. So I really like stem and leaf plots to compare values for like grades on something. They're a very good visual representation, so let me show you. These are the grades on a first exam, 87, 94, 82, and so forth. And we're going to make a stem and leaf plot for the data. Now, we're going to have one that's going to be sort of a working copy, and then we'll make our final copy, and I'll show you why. If you can and want to just jump to the final copy, that's fine. I find myself more likely to make a mistake if I try, so I just do a mock-up copy first, and then I'll show you how we reorganize it. So I'm going to make a line on the left. I need to know, kind of like on the last one, what's my smallest and my biggest value. So what is the lowest value you see in this table? 43. And the largest? 94. Okay, so what that tells us is that we're going to do 40-something, 50-something, 60-something, 70, 80, and 90, and I'll make my vertical line longer. So those are the stems. They're the tens digit for all the grades. And then what we're going to do is we're going to go piece by piece down. You know what? This is going to be a great footrest. Just watch me. There we go. Okay, we're going to go piece by piece through our data values, and we're going to write the leaf next to it. So when we see an 87, it's going to be in the 8 column or in the 8 row, and we're going to put a 7 next to it. And I don't need to worry about spacing or about clarity. I'm just getting them all into there right now. And I like to do that in sort of a arbitrary order because that way I don't miss a data value. Because I'm just going to go and I'm just going to go from left to right. So I have 76, 94, 58, 82, 43, 89, 53, 67 and 80, 90, 94, 74, 77, 87, 74, and 89 and 90. Okay, everybody good so far? We're just getting them, it's sort of like you're categorizing them. So it'd be like flipping through a set of papers, and the first thing that you're doing in trying to put them in sort of numerical order is you're just grouping all the A's together, all the B's together, all the C's together. That's equivalent to what we're doing here in a numerical form. So a stem and leaf plot in its final form, however, they need to all be in order on the leaf side. So that's the next step then. And so I'm going to write down my same 4, 5, 6, 7, 8, and 9. So obviously some of them don't have a lot to do. It's just 43. But the next one, it was an 8 and a 3, so I'll put the 3 first and the 8 second. And I have a 67. Do be careful as you're doing this final copy that they're lining up, right? So I wanted to make sure that the 7's not here, right? It shouldn't be there. It should be right underneath the 3 that was there before in the first sort of column to the left or the right of the stems. All right, so in my 70s column, I have a 4, 4, 6, 7. So I have 4, 4, 6, 7. Notice in my 80s column, I have a 0 and then a 2. And then I have 7, 7, 9, 9. And then in the 90s, I have 0, 0, 4, and 4. And everything seems to be lining up pretty well, visibly. So why do I like this? One of the reasons I like it is because at first glance you can tell me how many, not necessarily how many, but which letter grade was most prevalent. B's, right? Most people got B's. Like that's the most prevalent grade was a B. You can also try and figure out sort of like where's the halfway point? How many people got above and below the halfway point? We'll call that a median later on. But you could sort of count from the top and count from the bottom and come to the middle value that way. So there's a lot of good things that we're going to think about to use this for later. But it puts everything in numerical order. I mean, I can go straight down and I can say, look, there was a 43, a 53, a 58, a 67, a 74, a 74, a 76, a 77, and so on. They're all in order. The only thing that's missing is a title. So a title here would be something like that these are grades from a first exam. We also need, either within the title or separately, but somewhere here, a key that says what these mean. So what does it mean for it to have this number on this left and this number on this right? So I'm just going to use the first one that's on the list, and I'm going to say that the 4/3, you can see where it came from, right, is a grade of 43. So you can use any numbers, it doesn't matter. It doesn't necessarily have to be a number on your table, but you do a left number, you do that vertical bar, and then the right number to indicate what letter grade that would be representing. Any questions on that? So it isn't so much of can you or can't you, it's just that they don't So these have sort of a typical form, and the commas, and there aren't commas there. Yeah. Like if you were doing it for your own benefit and so forth, could you? Sure. But for the purposes of saying this is a stem and leaf plot by definition, no. Yeah. Okay, so this is stem and leaf plot. Our continuation, did you guys have a question? Are you good? You good? Okay. A continuation of this topic of stem and leaf plots is what's called a back-to-back stem and leaf plot. What this is it's two stem and leaf plots put back to back. I know, it's crazy, right? It actually is a way of comparing data sets. So one of our data sets will look, I'll flip back here just a second, just like this one, right? It'll look just like this. But the other one will actually have a line here, I'll delete this here, and it'll build going the other direction. The numbers will all build to the left. So we're going to take that data that we just created the stem and leaf plot for already and compare it to another set of data using a back-to-back stem and leaf plot. So these are the grades from a second exam. And, yeah, I thought I had space. What we're going to do first then is we are going to create our second exam's stem and leaf plot and just write it just like we did the first one. So we're just going to create another stem and leaf plot with this data just like we did before. And then I'm going to show you how we merge the two together for comparison's sake. Now, because we're comparing an earlier to a later value, the first exams are going to go on the left and the second exams are going to go on the right, just because there is actually an ordering to what we're talking about, one happening before the other chronologically. Bailey?
Does this only work with two-digit numbers? Like, what if it's doing that?
It's a good question. So it isn't so much that it works with two-digit numbers, it's that it works with two-digit values. So like you could do it for decimal places, right, where you had like, think about GPAs, you know, like a 4.0, a 3.0, a 2.0. You could do it with GPAs if you're doing it just to one decimal of accuracy. If you have, like we have here, oh, it isn't on this one. I think there's one maybe in your homework where there's a score of a 100 or something. You could have a stem that had a two-digit stem if most of the other things already just had one-digit stems. It would be appropriate. Does that make sense? But yeah, it's mostly used for two-digit values. Okay, so just like before, I'm going to create a sort of working copy and then my final copy of my stem and leaf plot. All right, so what's my smallest value?
No, 66, sorry.
There's one lower. 64. Yeah, it is in the 60s though. And then 99. Okay, so I don't need quite the same data spread as I had before. I need a 6, 7, an 8, and a 9. And we'll talk about how we make amends to merge these together when they don't quite match on that too. We're just going to go down the list. 93, 96. 98, 66. 67, 82. 92, 85. 64, 81. 86, 72, 96, 95, 99, 95, and 94, 74. And then we're going to create our final version of it, which is going to be putting that in order. I'm not going to do a title for it because this isn't really what I'm being asked to find. This is sort of me working on an in-between step, right? Getting this particular set of data in order. So 6, 7, 8, and 9. We have 4, 6, and 7. 2 and 4. 1, 2, 5, and 6. 2, 3, 4, 2 5s, 2 6s, and then 8, 9. Does that look like it? Okay. So I'm going to copy paste this. If you've got the space, you can build on the one you've already done. I need this to compare with my previous set, which had a stem of a 5 and a 4. So I'm just going to extend it up. And I'm going to use the same stem and leaf plot I did before, but I'm going to build it backwards. So 43 and then 53 and 58. So it looks like this. We'd have a 43. And then we'd have a 53 and a 58. And you can see how they're going backwards now, away from the center, right? So they're in reverse order. Then we had 67, 74, 4, 6, and 7. We have an 80. And an 82, and a 7, 7, 9, and 9. And then in the 90s, we have 2 zeros and 2 4s. So what is the comparison to be able to be made? Well, you can definitely see just at a glance, right, without a list of data values in sort of long form like this, or comparing those specific values. Oh, look, the second test had a bunch more A's, right? It almost looks like things kind of almost shifted from the lower values down into the bigger part of to the lower part of our graph, into those higher values. You can actually also talk about, just very quickly visually, even your lowest scores are better, right, on that second exam. So you can make visual assertions based on this particular graph. And then we'll do the same thing that we did before, where we need to give it some kind of a label and title. These are the first and second, and by the very nature of the writing it first and then second, you can see the ordering of it. Exam scores. I'll say exam score comparison. And again, we need to have some kind of a scale. So we'll do that same. Let's take one where it has something on both sides. How about I do the 60s column, where it looks like this. So we'll do it just like that, since I have 3 values. Where this, whoops, changed red, would be a 67 on exam 1 and 64 on exam 2. Does that make sense? Okay. Okay, our next one, we're going to shift gears a little bit. We're going to talk about a grouped frequency table. A grouped frequency table shows how many times data occurs in a range of classes or intervals. So what happens when you do a group frequency table is you lose the specific data values because you've grouped them in some way. So for grades, right, we have natural groupings. We call them letters, right? So when you look at your transcript and it says A, nobody knows whether you got a 99 or a 90.2, right? Nobody knows. It's all an A. So you lose something in an effort to sort of minimize the differences of other things too, right? There's this trade-off. So we're going to use the data values that we had from the second exam, and we're going to use the standard grading scale, right? 60 to 69, 70 to 79, that kind of thing, to make a grouped frequency table showing the letter grade disbursement for the grades on a test. So our disbursement kind of looks like when we did the stem and leaf plot. We have a vertical line, but instead of writing down 6, 7, 8, 9, we're going to write down what the group is. This is 60 to 69, 70 to 79, 80 to 89, and 90 to 99. So instead also of wanting to keep those specific values like we did over here by recording every detailed piece, what we're doing is we're just going to make tally marks. So we're going to have a column that's going to be a tally mark column of our values. So I have 93 and 96, 93, 96, 98, 66, 98, 66, 67, 82, 92, 85, 64, 81, 86, 72, 96, whoops, we can do them as hash marks over. So there's 96, 95, 99, 95, and 94, 74. I think that took care of it. And then our last column is just the numerical value associated with that tally mark. And so it's called the frequency, as in how frequently did it occur. So this is 3, 2, 4, and 9. You lose accuracy, but visibly, I don't have to look over here and, if I wanted to know, and count. Well, how many A's were there? Well, here I would have to count. Here, it's already written in for me. So there is a little bit of that trade-off. Still need a title. So these are grades on a second exam. And we'd be done. Now, sometimes you are not given, it's the standard grading scale, right? But what is important is that your classes have the same width. So sometimes it's nice to do things in groupings of 10, right? Because if we go from 60 to 69, that's 10 values. You guys recognize, yeah? There's 10 different data values that could fall inside of there, or numerical values. So maybe you're doing them in increments that are 5s. Maybe that makes sense with your data. Sometimes they'll tell you things like you have, they want you to do it in 7 classes. So you take your smallest number and your biggest number, and you might shift them a little bit if you wanted to, or something like that, right? Like if the smallest number is a 32 and the biggest number is a 97, you might decide to go from 30 to 90. That might make things easier to do the division and put them in the right number of classes or something like that. And then you just divide them into equal size classes. That's what that would look like. A histogram, you've seen used before. Probably histograms and bar graphs are the most common ones you would see used at this point in your academic career. We're going to use, they're made up of adjoining rectangles or bars. Adjoining means they touch each other. Okay, the bars touch. It's really important for you to write that down because we're going to talk about another graph later called a bar graph that feels very similar to a histogram, but the bars don't touch. Okay, so in a histogram, the bars touch. The categories are shown along the horizontal axis, and the frequency is along the vertical axis. So you'll notice that I keep using the same sets of data over and over again because it's not the data that determines what you're doing, it's what you're being asked to do with it. So there's no reason for us to keep changing our data set every time when we're just learning the different kinds of things we can do with the data. So we're going to use that same data that we just had, which we already created a grouped frequency table for, and we're going to construct a histogram. So this will show the numerical disbursement of the data from exam 2. So we're going to draw a horizontal and vertical axis like this. We know that our data values over here went from 60 to 99 in our classes. So we need the values marked here to go from 60. You might as well write it down to 100 because it's in hash marks of 10s. That makes sense. So we've got 70, 80. These should be equally widthed. That wasn't quite. 90. We have 100. So along the bottom is always what the values represent. Here, that's grades, and you do need to label your axes, much like labeling scale when we did like a pictograph. These are grades. Okay, we'll put the grades on a second exam part when we write our title, but these are grades down here at the bottom. And then on the vertical axis is going to be how frequently they occurred. So you can see over here we need frequency to go all the way up to 9. That's as big as we need to go. Does that make sense? So over here, again, depending on how big the frequency distribution is, will depend on how much you mark things up. So I'm going to make my hash marks in ones because 9's not very big. So this is 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to go ahead and put 10, and I'm going to label all the even ones. If you want to label them all, you can, but there comes a point, depending on how big you've done them, that it starts to look messy just because there's so much on there, right? Cluttered and that kind of stuff. So I'm going to label my evens. And what this is over here is this is the frequency. Okay, are we good so far? Okay, so frequency. How many were in the 60s range? 2, right? 3? What was it? 3. So what we need is we need a rectangle of height 3. Okay, it's going to go from 60 to 70, and it's going to have height of 3. So visibly, I've got a cool rectangle tool, so I should definitely use it when I have an opportunity, so I'm going to. Yeah. So we're going to make this from 60 to 70, and we're going to do it as a height of 3. What is our value, our number of frequency in the 70s? 2. So we need a height of 2. How about in the 80s? 4. So we'll do it with a height of 4. Your rectangles do not have to be perfect. And then our last one is at a height, or in the 90s, is at a height of 9, right? That's better. That's pretty close. There will be reasons later why we might want to shade them in. So if you just want to be in the habit of shading in your bars, you can. It really doesn't matter that much now. We often will see histograms where they're shaded in. The reason that they set next to each other, right, is because the values, there's no space in between them, right? They're not differentiated in that way. They're sort of on a continuum of grade values. So we see this continuum of bar heights. And we need a title. So obviously our title, much like it had been previously, would be grades on a second exam. And this is actually a really good place for us to pause. So we're going to pause right here. One thought, if you have them for next time. If you have a protractor, I would encourage you to bring one with you next time. I will have protractors as well. So if you don't have one, don't fret, don't go buy one. It is not worth buying one for the purposes of our discussion here today. But if you have one and you would want to bring one next class period, we will use them. Okay? Lovely.